चलिए। तो हम लोग बात कर रहे थे कि हम लोग मैग्मा पढ़ चुके हैं, आईयूजीएस में हमारा प्लूटोनिक रॉक कवर हो गया है। टुडे आई विल ट्राई टू कवर volcanic igneous rock, volcanic igneous rock. And we all know कि our the basis of classification of IUGS or especially plutonic igneous rock is your model mineralogy. Okay, why model mineralogy? Because in plutonic rocks we have a bigger grain size, so you can easily identify the minerals
Those
and crystals in the field as well as in microscope. But volcanic rocks have very fine grain rocks. It has sometimes glasses, so it is too fine to read even in the microscope. So that's why we to class for the classification of volcanic igneous rock, we need we can't classify volcanic igneous rock with the help of minerals, but we can classify with the help of chemical composition. And then this chemical composition will further convert it into different components, and then it will be correlated with the minerals. So accordingly you can correlate these volcanic rocks with their chemical equivalent plutonic igneous rocks. So we can classify our volcanic igneous rock with the help of chemical composition. Okay, so so we are reading igneous rocks, so silica amount of silica percentage is play very important role, because in igneous rocks is basically made up of silicate minerals, and you can see in the Bowen-Dixon series all the minerals which is available in this Bowen-Dixon series is belongs to silicate family, silicate mineral groups. So as you go down from top to bottom in the Bowen-Dixon series, your percentage of silica amount is increasing, and your sodium and potassium amount is also increasing.
increase.
So in the Bowen-Dixon series you can find all kinds of igneous rocks, whether it will be your mafic igneous rocks or intermediate igneous rocks or felsic igneous rocks. So we know ki our parent magma is basaltic. Okay, basaltic melt is the parent magma or parent melt, and your Bowen-Dixon series is derived from this basaltic melt, basaltic magma. So to classify volcanic rocks, I will choose these two important components, which is increasing continuously when you move from mafic to felsic rocks or from basaltic to rhyolitic rocks. So with the help of these two component, basically especially sodium oxide Na2O and K2O, it is also called alkalis, and this is SiO2 which is called silica. So I will try to construct this this chart or this two axis uh, graphical diagram in which is this y-axis, suppose it it represents alkalis Na2O plus K2O, and in this direction it increases, and this axis represents silica percentage. So with increasing silica amount and with increasing alkalis, we will try to classify different volcanic igneous rocks. You are looking smart, sir. Volcanic igneous rocks. Okay. So now see, in the rock we have so many components. No? Sir, for example, we have iron oxide in the mafic rock, we have magnesium oxide, we have alumina Al2O3, we have calcium oxide, we have sodium oxide, potassium oxide, silica. We have so many components that basically varies throughout the magmatic evolutionary path, throughout the magma series. When your magma is moving from mafic to intermediate, intermediate to felsic, there has been variation taking place in the composition. So this compositional variation has been taken place throughout the magmatic evolutionary path when your magma evolved from the mafic to felsic. So changes has been taken place in all these components. Okay, but to represent all kinds of mm, volcanic igneous rock, we will use just these two components. Okay, so this will be at this axis and silica will be at this axis. Why we choose these two component only? Can anyone tell? Can anyone explain the reason behind why we are choosing these two component to classify different volcanic igneous rocks?
Sir, sir, majorly we found these elements in calcic igneous rock.
What? Can you explain again?
वॉइस कट गई सर आपकी।
आप फिर से बताइए।
Sir, majorly we found these elements, potassium, sodium, silica rich, and last part of the bounce fractions rich. So, तो जो भी rock मिलेगा तो ये component ज्यादा मिलेगा sir.
Because these silica is continuously decreasing from top to bottom, so your silica is mostly represents all kind of rocks. Okay, so these mafic rocks is silica undersaturated rocks, but your felsic rocks is silica oversaturated rocks. Okay, silica oversaturated rocks, but this sodium oxide is represents lower part also. So end product is basically this is ultimately this is found in the end product. So if we choose just suppose iron and magnesium, then it will be finished here up to here. Okay, the moment you made mafic and intermediate rock from the parent basaltic magma, and the moment your olivine pyroxene amphibole crystallize from the magma, then how you will end up these rocks if you will not take these two component. So these two components, silica is especially very important, and sodium oxide is found in the end product in the dairy in the ultimately in the last product of magma series. So these two compositional components units are most they are mostly represent your magma evolution. Your or you can say your compositional variation has been mostly represented by these two components. So that's why we will choose these two things. But it is very important that these things also consider but not represented here. But it is hidden, but it is also considered in the classification of different volcanic igneous rocks. So these things will clear further. Just we are moving. Now uh, see this PPT, then you will understand very well. Yes. So are you people able to see this diagram?
Yes, sir.
So
Yes, sir.
here whatever the rocks is whatever the things is written here is your volcanic igneous rocks. You can see this is basalt, this is rhyolite, this is trachyte, this is phonolite, isn't it? So all are basically volcanic rocks. All are volcanic rocks. So all the rocks which is mentioned here, it is your volcanic rocks. This is the very first thing. And what is the another thing? Here you can see all kinds of volcanic rocks. All kind of volcanic rocks from mafic to intermediate to felsic. For example, your rhyolite is felsic rock. It is the volcanic equivalent of granite. Your andesite is intermediate rock. Its plutonic equivalent is diorite. Your basalt is mafic rock. Its plutonic equivalent is gabbro, isn't it? So, and picrobasalt is olivine rich basalt. So it is sometimes considered ultramafic rock. So here this chart is represent all kind of volcanic rocks. And here because this is volcanic rock, so it is very fine grain size. It has very fine grain size. So it is very difficult to identify minerals. So that's why we try to classify these rocks by using silica component, which is increasing in this direction. Here you can see from 37 to 77% silica wet percent. And this axis represents alkalis, wet percent alkalis. So you can see here Na2O plus K2O. Okay. So this is called alkalis, which is increasing in this direction. With the help of sodium, potassium, alkalis, and silica component, we are going to classify different kinds of volcanic rocks here. Okay. So
Yes, sir.
now see. Okay. So can you tell me what is the difference between mafic uh, and felsic and your basic and acidic? Can you tell me the difference between these two, Wahida?
Yes, sir.
Hmm.
Mafic and felsic is mineralogical compositional term,
Hmm.
while is basic and acidic is chemical compositional terms.
Very good. So your mafic and felsic terminology is basically used to define which minerals is present in the rock. So generally your mafic and felsic term use for use for use for
Chemical composition.
Mineralogy, sir.
plutonic igneous rocks, because in plutonic igneous rock you will identify minerals.
Yes,
Okay.
sir. Modern
And your
terminology.
basic and acidic term is used for chemical composition, and this is mainly used to basic and acidic term is used to define, is used to explain volcanic igneous rocks. Volcanic igneous rocks. Okay. So both are similar. Your mafic is very much synonymous with the basic. Your felsic is very much synonymous with the acidic. Acidic must means siliceous rock.
Yes, sir.
Basic means mafic rocks. Okay. Felsic is also known by the term siliceous rock. Okay. Siliceous. So here you can see. So now your ultra mafic can be written here as ultra basic. Okay. Your basic rock is written as you can matlab is
Mafic.
instead of mafic you can write here basic, because you are classifying these rocks on the basis of chemical composition, not on the basis of minerals. Intermediate will be same, and at this at the place of felsic you can write here acidic. Okay. So as you move from left to right, you are basically moving from ultra basic to acidic rocks. It means you are moving towards where wet percentage of silica has been increasing. So now here you can see uh, if 45% less than 45% is silica, then your rock will be ultra basic or ultra mafic. If your silica percentage range from 45 to 52 or 53, it will be basic. And in the same way, when you have more than 65% or more than 63% felsic silica component, then it is your acidic or felsic rock. I told you in the earlier classes when we learn magma types, then I told you people we have three kinds of magma. We have basaltic magma, which is called mafic magma, or you can say basic magma. And in the same way, we have intermediate magma, which is also called acidic magma. Sorry, andesitic,
Andesitic.
Andesitic magma.
andesitic magma. And we have felsic, rhyolitic magma, or
Felsic.
acidic magma, or felsic magma. Okay.
Granitic magma.
So I told you ki your mafic magma has very less amount of silica component. It has mainly 45 to 55% SiO2. Okay. But to suppose if your 45 to 55 represents basaltic magma, then less than 45 represents less than 45 represents less than 45 represents when your 45 to 55%
Ultramafic.
ultra mafic. Ultra mafic or ultra basic. Okay.
Ultramafic.
In the
Ultra
same
basic.
way, in the same way, 55 to 65 is your
Ultra basic.
silica amount. Silica is your intermediate, and more than 65% silica is
Ultra basic.
represents rhyolite. Okay. So now see. So these things is also represented here as seen here. More than 63 or 65 is acidic.
Acidic.
Less than 45 is your ultra basic. And here in this axis, your alkalis amount has been increases. Okay. So this is your rhyolite. In QAP diagram, you have read this thing now. In QAP, this is felsic rock. So this portion is for granite. It means this portion is for rhyolite also, in which you have equal amounts of quartz and feldspar. And where you read this foidite? Foidite you have read in this the same diagram in the lower triangle. ठीक है, आ रही आवाज?
Yes, sir.
आ रही है ना भाई आवाज?
यस सर आ रही है।
अब तक स्मूथ चल रहा था ना, सब कुछ समझ में आ रहा है ना?
जी सर थोड़ा वॉइस ब्रेक हो रहा है सर आपका।
अच्छा। हम्म अभी ठीक आ रहा है, क्लियर है?
जी सर अब ठीक है।
चलिए, तो सपोज योर this portion is for rhyolite, and what is here? What is here? This is feldspathoid. So here we have foidolite in plutonic, and its volcanic equivalent is foidite. So I told you na ki this triangle is for silica undersaturated,
सिलिका saturated,
and this triangle is for silica oversaturated. Oversaturated. So that's why your rhyolite is silica oversaturated rock. That's why you can see here you have most amount, very large amount of silica percentage is there, and your foidite is basically silica undersaturated. So that's why you can see this is located in where your silica amount is very less. Okay, foidite, है ना?
Yes sir.
And another important thing is that your this portion represents what? Can you tell me?
White cyanide.
This portion represents white cyanide, means nepheline cyanide. Then what will be
Yes, sir.
the volcanic equivalent of nepheline cyanide?
Phonolite.
Phonolite. So your phonolite is represent here. This is your phonolite, isn't it?
Yes sir.
So what it means ki your phonolite is very much close to alkali feldspar, which is potassium to sodium. Because your alkali feldspar in this feldspar triangle we have orthoclase, we have albite, we have anorthite. So this is your K feldspar now. And basically it is written K feldspar, but it is originally alkali feldspar, which compose both potassium and sodium also. Potassium from orthoclase and albite from sodium from albite. So this alkali feldspar series from albite to orthoclase is it contain both potassium and sodium both. Okay. ठीक है?
Yes sir. Yes sir.
Yes, sir.
यहाँ तक क्लियर है ना? तो it means कि your phonolite is very much close to alkali feldspar, means it is rich in sodium and potassium. So that's why phonolite is written at very top, because it has high amount of sodium and potassium.
Alkali feldspar.
So now can you tell me so now it is written here, it means ki your phonolite is most alkali rich rock. It is most alkali rich rock. The phonolite is most alkaline rock. Okay. Which is most siliceous rock here? Which is most siliceous rock here?
Rhyolite.
Rhyolite.
And which is least siliceous rock here? Least?
Foidite.
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 So foidite is least siliceous rock, rhyolite is most siliceous rock, phonolite is most alkaline rock. ठीक है?
Yes, sir.
Okay, sir.
Now I am going to tell you another important thing, which is called magma series. Okay, which is called magma series. So your magma series means, what do you mean by series? Series matlab sequence. Okay, just like web series. Web series, it means there is a web series in which you have a sequence of episodes, 10 episode, 20 episode, like that. Then what do you mean by magma series? It means your different magma is aligned in particular sequence. It is arranged in particular sequence. Okay. So magma sequence means when you are moving from ultramafic rock to mafic to intermediate rock, intermediate to felsic. So if your magma is evolved like that, if it follows this path, so this is called magma series. So can you call also rock series? Is there any difference between magma series or rock series? नो डिफरेंस, बिकॉज योर मैग्मा इज मैग्मा ही तो है जो कन्वर्ट हो रहा है रॉक में, मैग्मा ही तो रॉक बन रहा है. तो योर मैफिक रॉक विल क्रिएट मैफिक मैग्मा विल क्रिएट मैफिक रॉक लाइक गैब्रो एंड बसाल्ट. Your intermediate magma will create intermediate rock, which is your andesite and diorite.
Right.
Your felsic magma will create felsic rock, right, like rhyolite and granite. Okay. So both are volcanic and plutonic equivalent of each other. So your magma series is sequence of different magma, and your magma, you know, when your magma evolve, it shows some variation in their chemical composition. So when chemical composition is continuously vary throughout the magma series, throughout the magma sequence, then it is called, and it each and every magma produce different kinds of rocks. So this things is called magma series, and the rock which is produced from this series is called rock series. Okay. So and each and every magma series which is produced, which is developed from the parent basaltic magma, that creates a relationship from earlier magmatic body. Suppose your intermediate magma is genetically related with the mafic melt. Your felsic magma is genetically related with the intermediate melt. So and this chemical variation in the journey of magma series is represented by different diagrams, and these diagrams is called variation diagrams because there is variation of chemical composition or chemical data has been taken place throughout the magma series when your magma evolved from the mafic to felsic, or from basaltic to felsic, or from basaltic to rhyolitic. Okay. So different magma has different names, and the rock which form from those different magmas have different names also. So your chemical composition play basis for the nomenclature of volcanic igneous rocks. And these volcanic igneous rock basically derive from the different magmatic body which is represented in the magma series. So just like your model mineralogy is the basis for the classification or nomenclature of plutonic igneous rocks, in the same way your chemical composition here is the basis for the nomenclature of volcanic igneous rocks, which is formed through different magma series.
Magma series.
Okay. So let me. So suppose with the help, because through magma series, suppose your mafic, then intermediate, then felsic, magma. These are magmatic bodies, or this is whole, it is called magma family. Magma family that varies, that evolve throughout through different processes, basically through magmatic differentiation process. So suppose, for example, from the mafic rock you will get basalt. From intermediate rock you will get andesite, then dacite, then from felsic you will get rhyolite. So you can see now ki how your magma evolve, and it produces different kinds of rocks. So this naming of the rock is basically, it is based on chemical composition. And what is the chemical composition we are taking generally is your sodium oxide and potassium oxide and silica amount. So these
SiO2.
two components we are generally taking, but hidden component is also there. Iron oxide, magnesium oxide, aluminum oxide also there. But because these two things play very important role, that's why we are taking these two parameter to classify, to nominate, or for the nomenclature of these rocks, which is evolved from the parent basaltic magma. And each magmatic body which is mentioned in this magma series is genetically related from the previous magmatic body. Okay. So your chemical variation data, chemical variability is generally used to distinguish these magma families, this magma family. And your magma series is also known by different names. So this is the example of magma series. Okay. Just like your web series is the group of different episodes, and each and every episode have their own names based on the theme of the story. And each and every episode in the web series is linked to each other. It is genetically linked, isn't it? The story evolved throughout the episodes, different episodes. And if you miss the first episode, it is very difficult for you to follow the story. So parent episode is your basaltic magma. Okay. The first episode of the web series is it is very much similar with the parent basaltic magma, through which different magmatic body has been evolved. So your magma series is also known by the name association, magma association, because it is in the group. It is also known by the term lineage, because it creates a linear path which is genetically evolved magma, which is genetically related with the previous magmatic body. Just like your 10 number episode has been related with the 9 number of episode in the web series. It is also called magma type. Okay. It is also called clan. You can also say magma sequence. Okay. So your magma series is nothing but it is the magma through which your igneous rocks has been formed, and each and every igneous rock, just like basalt, andesite, dacite, and rhyolite, is distinct, or it is follow a very characteristic evolutionary path, and it develop or it produce from a very unique type of parent magma, which is your basaltic magma. And throughout a series, your magma shows compositional variation, and it will evolve finally uh, as a more silicic derivative. So your rhyolite is the most siliceous rock. So it is the end product of your magma series. It is the end episode of the web series, which is basically silicic in nature, siliceous in nature, or silicic in nature. So I'm giving this this as an example of magma series, but we have so many kinds of magma series. We have lots of magma series. This is the very first one. I am taking this series as example here. So we have generally two major kinds of magma series. Two major kinds of magma series. Can you tell me which one two kinds of magma series is? Hmm? क्यों वहीदा?
Yes, sir.
Hmm. Can you name? Can anyone name what kind of magma
Yes.
series is there? Basically, there are two kinds of magma series: alkaline magma series and subalkaline magma series. Okay. Do you all people follow all the things? आशीष जैन, समझ में आ रहा है ना जो चीज़ हम डिस्कस कर रहे हैं कि नहीं आ रहा है?
Yes, sir.
क्लियर है?
Yes, sir.
लक्ष्मण, क्लियर है तुमको?
Yes, sir.
एंड सिमिका,
Yes, sir.
अब तक जो हम पढ़े हैं उसको फॉलो कर रही हो? बहुत तेज तो नहीं हो रहा है ना?
Yes,
बहुत
sir.
No, sir.
बहुत जल्दी जल्दी तो नहीं हो रहा है ना लेक्चर? मतलब लेक्चर स्मूथ चल रहा है ना?
No,
ऐसा तो नहीं लग रहा है कि बहुत तेज हम चल रहे हैं या स्लो चल रहे हैं?
no, sir.
स्पीड सही है ना?
हाँ सर.
शर्मिष्ठा, तुम फॉलो कर रही हो?
हाँ सर.
तो तुम
हाँ सर,
बोल
समझ
क्यों
में
नहीं
आ
रही
रहा
हो? बोल क्यों नहीं रही हो तुम यहाँ पे? तो तुमको बताना चाहिए था ना कि कौन सा मैग्मा सीरीज होता है, तुम्हें तो पता होगा।
है. कैलकुलेशन में इसमें थोड़ा कंफ्यूजन हो रहा है. सालकलन की जगह कैलकुलेशन याद आ रहा
अच्छा।
है.
हम्म, ठीक है, कोई बात नहीं। तो योर मैग्मा सीरीज इज टू काइंड्स, अल्कलाइन एंड सब अल्कलाइन, and
Yes.
basically your subalkaline is divided into two part: thalliatic magma series, thalliatic and calcalkaline. Thalliatic and cal calcalkaline. So as the name suggests, your alkaline magma series is rich in alkalis. Okay, rich in alkalis. Rich in alkalis मतलब rich in sodium oxide and potassium oxide.
Potassium oxide.
And your subalkaline means, सब माने क्या होता है? What do you mean by sub? सब माने थोड़ा कम ना, थोड़ा पुअर, थोड़ा नीचे।
Yes, sir. Half.
हाँ, हाफ भी हो सकता है या बहुत, हाँ हाफ और कम भी हो सकता है। तो सब अल्कलाइन मतलब पुअर इन अल्कलीज, पुअर इन
Yes, sir.
अल्कलीज। ओके, सो and another important thing is that your subalkaline magma is rich in silica content. So सिलिका कंटेंट में रिच होगा तो क्या बोलेंगे? सिलिका सैचुरेटेड टू, सिलिका सैचुरेटेड टू सिलिका
Surety.
ओवर सैचुरेटेड। और ये जो अल्कलाइन मैग्मा होता है ये सिलिका पुअर होता है, इट इज पुअर इन सिलिका। तो सिलिका पुअर होगा
Yes.
तो क्या लिखोगे इसको? सिलिका
Undersaturated.
Silicon
Undersaturated.
undersaturated.
सैचुरेटेड।
Undersaturated.
ठीक है, नाउ सी। अब यहाँ पे बताओ, अगर मान लो कि अगर हम एक डायग्राम बनाए यहाँ पे और यहाँ पे लिखते हैं अल्कलीस Na2O plus K2O, okay, it is increasing here, and here I will write silica, it is increasing here. So can you tell me where I should write alkaline, where I should write subalkaline? बताओ।
Alkaline 1.
Sir, one is alkaline
One alkaline and 2 for sub-alkaline.
two subalkaline.
One is alkaline and two is alkaline.
Okay, so it means your alkaline is rich in sodium and potassium oxides and poor in silica, and your subalkaline is rich in silica and poor in alkalis. Okay, So this is your silica undersaturated and this is saturated to oversaturated. ठीक. And generally your alkaline magma series is found in Pacific Ocean, na? Remember, in the Pacific Ocean alkaline magma series is found, and in Atlantic Ocean your subalkaline magma series found. And at the place where very first time your alkaline and subalkaline magma has been read by different scientists. So I don't know the exact location, but there is a place which is called Plateau. So where this alkaline rock is very first time read by the geologist. So your alkaline magma series is also known by the term Plateau magma series. Plateau magma series. Remember, sometimes कभी पूछ भी सकते हैं. Otherwise बहुत important नहीं है ये. And your subalkaline magma series is known by also by known main magma series. ठीक है. And you all know कि subalkaline magma series is further divided into Tholeiatic and calc-alkaline. So Tholeiatic और calc-alkaline ये भी क्या होगा? Tholeiatic और calc-alkaline ये भी क्या होंगे? Tholeiatic और ये भी क्या होंगे? ये भी क्या होंगे? सिलिका सैचुरेटेड तो सिलिका ओवर सैचुरेटेड होंगे एंड पुअर इन अल्कलीज होंगे.
हाँ सर.
Tholeiatic calc-alkaline also poor in alkalis and rich in silica. ठीक है.
Yes, sir.
तो शर्मिष्ठा तुमको मजा आ रहा है कि नहीं ये क्लास करने में?
हाँ सर, ये मैग्मा सीरीज तो अच्छा लगता है मुझे. इग्नियस.
ठीक है. तो नाउ सी so now we are basically classifying magmatic groups या magma family from basaltic to felsic. So we can we will distinguishing these magmatic groups with the help of chemical parameters or chemical composition, and especially sodium and potassium oxide and silica component. Sometimes alumina is also taken for classification because it is also very important ingredient. Now see this this diagram. So this is your silica component, this is your alkalis. So now can you tell me, this is the line. So this area will be subalkaline magma series. Okay.
Yes, sir. Yes, sir.
Subalkaline magma
Series.
and this area will be
Alkaline magma series.
so what do you mean by this कि your basaltic andesite dacite and rhyolite is belongs to subalkaline magma series, and your basaltic trachy andesite, trachyite, and your this line tephrite, phonotephrite, tephriphonolite and phonolite, all these rocks belongs to alkaline magma series. यही तो हुआ इसका मतलब.
Yes, sir.
है ना? And this portion is the part of this shaded area.
Yes, sir.
This shaded area. So this your trachy basalt, basaltic trachy andesite, this is also belongs to alkaline series. होगा कि नहीं होगा?
Yes, sir.
तो ये वाला सीरीज क्या कहलाएगा?
Yes, sir.
What do you call this series? This is also alkaline series, isn't it? अरे भाई जब ये वाला सीरीज ये पूरा सीरीज अल्कलाइन है तो ये भी तो अल्कलाइन होगा क्योंकि ये तो इसी का डेरिवेटिव है ना. ट्रेकी बसाल्ट को ही 2 में डिवाइड किया है ना. अच्छा ये मैंने तुम लोग को पढ़ाया नहीं अभी ना ये बात. let me see, this is your shaded area. So this is one series, this is another series in which you have trachy basalt, basaltic trachyandesite, and trachyte. So see, your major rock is triolet here, your major rock is trachyte here. So your uh, your trachyte and dacite, when combined together, they will create trachydacite. In the same way, your trachyte and andesite create trachyandesite, and your trachyte and basaltic andesite will create basaltic trachyandesite, and your trachyte and basalt will create trachybasalt. Okay. So these are basically intermediate rocks, which is made up with the help of trachyte and andesite, with the help of trachyte and andesite, with the help of trachyte and basaltic andesite, and with the help of trachyte and basalt. Thick. And this is your another sequence which is generally located in the lower portion of the IUGS classification में अल्कली फेल्सपार प्लेजिक्लेस एंड फेल्सपाथोइट से मिलके बनेगा, क्योंकि आपका यहाँ पे आता है फोनोलाइट, यहाँ पे आता है आपका बेसानाइट एंड टेफ्राइट, which is located here, बेसानाइट एंड टेफ्राइट, which you will can distinguish with the help of olivine percentage. If olivine is less than tephra, more than besanite. If more than 10% olivine, then besanite. So I told you all these things, and this portion is for voidite, isn't it? Which is written here. So generally, this particular portion is represented by this lower triangle, okay, which is made up of alkali feldspar, plagioclase feldspar, and feldspathoid. But this shaded area is made up of upper triangle, because your trachyte is located here. It is the volcanic equivalent of cyanite.
Yes,
Okay. And baki, these are you all know. So this shaded area is further categorized on the basis of whether it will be potassic in nature or whether it will be sodic in nature. So if trachy basalt, which is here, trachy basalt, if sodic, then it is called Hawite. If it is potassic in nature, then it is called same. Potassic will add here, and all are remain. Trachy basalt all remain, but potassic trachy basalt कह दो. So see this basaltic andesite, basaltic trachyandesite. If it will be sodic, then it is called mugierite. If it is potassic, then it is called sosonite. And in the same way, see this portion, trachyandesite. If it is potassic, then latite. If sodic, then benmorite. ठीक है ना? और लेटाइट तो तुम लोग पढ़ ही चुकी हो. यहाँ पे लेटाइट, ये दिस इज द लेटाइट, इट इज द volcanic equivalent of monzonite, है ना? So अब देखो, so now can anyone define what is mugierite? कोई ऐसा है जो डिफाइन करे mugierite क्या है? This mugierite. Hello.
Sir, when basaltic trachyandesite contain greater percentage of sodium content Na2O percentage, then it is called, as compared to K2O percentage, then it is called muggerite.
चलिए कोई और बताए? Anyone else who wants to define mugierite? आशिया तुम बताओ.
greater to greater potassium muggerite or less than potassium.
तुम बताओ आशी जैन.
सर सोडियम का परसेंटेज ज्यादा होगा तो उसे मुगियाराइट बोलेंगे, और पोटेशियम का कम होगा तो उसे सोसोनाइट।
लक्ष्मण तुम बताओ, व्हाट इज मुगिया राइट?
I don't know.
शर्मिष्ठा तुम बताओ।
ये एक वोल्केनिक इग्नियस रॉक है जहाँ पे सोडियम ऑक्साइड 2.2 से ज्यादा है और इक्वल हो सकता है, और K2 कम है। और हाँ, K2 कम है। ठीक है।
तुम थोड़ा बहुत ठीक बताइयो। सिमिका तुम बताओगी?
सर सिलिका का कुछ बोलना पड़ेगा क्या?
सिमिका तुम बताओ।
सोडियम रिच ट्रैची एंडेसाइट, जिसमें सोडियम पोटेशियम का रेशियो ग्रेटर देन 2 है।
देखो अब इसको ऐसे डिफाइन करना, आगे से ध्यान रखना। हमने पूछा कि व्हाट इज मुगिया राइट, ओके। सो एट द वेरी फर्स्ट, द वेरी जो सबसे पहली चीज है वो जो तुमको बोलना है वो ये बोलना है कि मुगिया राइट इज वोल्केनिक इग्नियस रॉक। सबसे पहली चीज कि एक वोल्केनिक रॉक है। अब दूसरी चीज ये इसमें बोलना है कि इट इज अल्कलाइन रॉक, क्योंकि ये कहाँ पे हमने इसको कैटेगराइज किया, इसको सेपरेट किया अल्कलाइन, इस ये लाइन इधर किया है ना, ये है ना। मुगियाराइट इज द
Yes, sir.
पार्ट ऑफ basaltic trachyandesite एंड योर basaltic trachyandesite यहाँ पे है। सो इट मीन्स इट इज इन द अल्कलाइन सीरीज में आ रहा है ना। तो ये वोल्केनिक रॉक है, अल्कलाइन रॉक है, अल्कलाइन मैग्मा सीरीज का रॉक है। उसके बाद दूसरी तीसरी बात यह है कि ये सिलिका अंडर सैचुरेटेड रॉक है, अल्कली रिच रॉक है, एंड स्पेशली विद इन अल्कलीज इट इज मोर सोडिक लेस पोटेसिक, और सिंपली यू कैन से इट इज सोडिक वोल्केनिक अल्कलाइन रॉक। ठीक है ना?
ओके सर।
Yes, sir.
तो स्टार्ट फ्रॉम द वेरी रूट, यू शुड ऑलवेज ट्राई टू आंसर द थिंग्स फ्रॉम द वेरी रूट। वोल्केनिक है, अल्कलाइन सीरीज से बिलोंग करता है, सिलिका अंडर सैचुरेटेड रॉक है, अल्कली रिच रॉक है, और विद इन अल्कली इट इज, अल्कली में तो दोनों आएगा, सोडियम पोटेशियम दोनों आएगा, तो विद इन अल्कली
So,
इट इज सोडिक इन नेचर।
sorry.
So this series Hawite, Mugiarite and Benmorite, or you can also add trachyte, because here when you go move here you will meet trachyte na. They all are the derivatives of trachyte and this subalkaline rocks. Okay. So when you move from Hawite to Mugiarite to Benmorite, or even you can write here trachyte. So this is, इस सीरीज का नाम बताओ क्या होगा इस सीरीज का रॉक? What is the name of this magma, this rock series?
Alkaline
और बताओ, अल्कलाइन सीरीज होगा, और अच्छे से बताओ। It is sodic alkaline series. It is sodic
हाँ सर।
Alkaline.
sodic alkaline series because here sodium is more than. यहाँ पे सही कर लेना, ये गलत लिखा हुआ है, ऐसे रहेगा। यहाँ पे पोटेशियम ज्यादा है, सोडियम कम है ना।
Yes, sir. Yes.
अब इस सीरीज को बताओ,
हाँ,
इस सीरीज को क्या बोलोगे?
पोटेशिक सीरीज,
Potassic alkaline
पोटेशिक
series.
अल्कालाइन सीरीज।
यस। पोटैक्सिक सीरीज क्या होता है? पूरा बोलो ना, पोटैशिक अल्कलाइन सीरीज। So your
हाँ
potassic
सर।
trachybalsalt, sosonite, latite, this is your potassic
Alkaline
alkaline
series.
series. सही है ना?
Yes, sir.
हाँ
Yes,
सर।
sir.
इस तरह से कोई बताएगा नहीं आपको, समझ गए?
Yes, sir.
No one teach
हाँ
you like
सर।
this. So you people are very blessed. I'm not
Yes, sir. We
telling
are.
you about myself, but मैं ये बताना चाह रहा हूँ कि इस तरह से पढ़ना बहुत जरूरी है, अदरवाइज इट विल बी वेरी डिफिकल्ट टू कॉम्पीट कंपटीशन में आने आने के लिए आपको ऐसे ही पढ़ना पड़ेगा।
यस सर।
सो ये बताइए इस सीरीज का नाम क्या होगा? दिस इज सब अल्कलाइन सीरीज,
हाँ सर।
and basically this series from basalt to intermediate rocks and then felsic rhyolite within this is subalkaline magma series, but within subalkaline this series especially this is calc alkaline series, calc alkaline series. Okay, this is calc alkaline series, and this series is your both sodic and potassic alkaline series. Okay, and sometimes this is also come under the category of alkaline.
Yes, sir.
So sometimes this is going like that, or sometimes this is going like that. So this path also come under the category of alkaline rock, alkaline magma series. ठीक है?
यस सर।
See this diagram. So this is again your alkali. This is silica. So see, this is subalkaline magma series. So subalkaline magma series will produce subalkaline rocks, and alkaline magma series will produce alkaline rocks. क्योंकि रॉक बनेगा मैग्मा से है ना, तो alkaline magma series will produce alkaline
यस
rocks.
सर।
Yes, sir.
And this is the line that separates these two fields. Here your alkaline, here your subalkaline, and you can see this is very siliceous silica increasing this way. This is very much alkaline in nature because alkali increases this way. So in subalkaline magma series, and especially if I ask the suppose especially I consider if calc alkaline series here, because calc alkaline is a part of subalkaline. So can you write here basalt,
Hmm.
then andesite, then dacite, and then rhyolite, isn't it?
Rhyolite. Yes, sir.
So this is the
Yes, sir.
series of calc alkaline magma series. उसी तरह अल्कलाइन में तुम यहाँ क्या क्या लिख सकती हो? यहाँ पे लिख सकती हो ना, बताओ क्या क्या लिख सकती हो? पिक्रो बसाल्ट लिख सकती हो, नहीं सॉरी सिंपल बसाल्ट से लेके चलो, बिकॉज बसाल्ट इज पेरेंट तो इट विल बी बोथ द प्लेसेस, है ना? सो बसाल्ट, फिर क्या आएगा? ट्रेकी बसाल्ट,
Tracky basalt.
फिर ट्रेकी बसाल्टिक एंडेसाइट, ट्रेकी
Yes, sir.
बसाल्टिक एंडेसाइट, और उसके
Tracky
बाद
andesite.
Tricky andesite.
ट्रेकी
Andesite.
एंडेसाइट, एंड इन द एंड यू विल ट्रेकाइट।
Trachyte.
Okay.
ठीक है, लिख सकती हो ना? अब अगर हम ये कहें कि हमको अल्कलाइन सीरीज में सोडिक अल्कलाइन सीरीज बनाना है, तब क्या लिखोगी? सोडिक अल्कलाइन बनाना है
Hava-
तो ट्रेकी बसाल की
White.
जगह पे क्या लिखोगी? हवाइट लिखोगी।
White. Yes,
इसके जगह पे क्या लिखोगी?
Mugera.
Mugierite
मोगियराइट, और
and
यहाँ पे बेनमोराइट,
benmorite.
बेनमोराइट। ठीक है, तो यार हवाइट, मोगियराइट, बेनमोराइट एंड ट्रेकाइट, दे आर सोडिक
Sodic
अल्कलाइन सीरीज
alkaline.
सीरीज और सोडिक अल्कलाइन रॉक्स। ठीक है,
Yes,
सोडिक
sir.
अल्कलाइन रॉक्स होंगे ना?
Yes,
और
sir.
अगर अगर
Yes, sir.
पोटेस
Yeah.
अगर पोटेसिक लिखना है तो क्या लिखोगी? इसको लिखोगी पोटेसिक
Potassic tracky basalt.
ट्रेकी बसॉल्ट, देन
Tracky basalt.
देन
Tonite.
Prosonite.
सोसोनाइट, देन
Latite.
Latite.
मोटाइट, और यहाँ पे
Latite.
ट्रेकाइट डाल सकती हो आगे, बट जनरली ट्रेकाइट को सोडिक में कंसीडर करते हैं, लेकिन ट्रेकाइट यहाँ भी लिख सकते हो। पोटेशिक ट्रेकाइट भी तो हो सकता है ना?
Yes.
हम्म। So here you can see कि your subalkaline magma series is divided into subalkaline magma series is divided into tholeiitic and calcalkaline magma series, and this variation or this ये जो इस तरह से हम फर्दर डिवाइड कर रहे हैं सबअल्कलाइन को, दो मैग्मा सीरीज में, इट इज बेस्ड ऑन AFM डायग्राम ना, इट इज बेस्ड ऑन टर्नरी वेरिएशन डायग्राम विच इज योर AFM डायग्राम। ये मेटामॉर्फिक में हम पढ़ाएंगे आपको AFM डायग्राम क्या होता है। F फॉर आयरन ऑक्साइड और Fe2O3, A for aluminium oxide, alumina, and M for magnesium oxide. Okay. So you can see here कि this is your calcalcline magma series, which is moving in this way. And this is your Tholiatic magma series. Okay. So this is your Tholiatic magma series. This is your calcalcline magma series. But this triangle is represents the whole triangle represents the whole triangle
Subalkaline.
Subalkaline.
subalkaline magma series. Okay. Subalkaline magma series, which is divided into calcalcline and tholiatic. It means your tholiatic is more iron rich because it's moving towards iron,
Iron rich.
and your calcalcline is more alumina rich because it is moving towards the alumina. ऐसे जा रहा है ना, और ये ऐसे जा रहा है, ठीक है।
Yes.
So now can you tell me कि
Yes.
what will be here, यहाँ पे क्या होगा, कौन सा रॉक होगा यहाँ पे, या कौन सा मैग्मा होगा?
MgO.
हम्म, कौन सा मैग्मा होगा यहाँ पे?
सर आज लक्ष्मण के और मानसी के फर्स्ट क्लास है, इनसे थोड़ा सा मैं इंट्रोडक्शन कर लेना सर। इनको शायद आज सर थोड़ा मुश्किल होगा समझना। कैसे समझ में आ रहा है
सर, बस।
मानसी? और बताओ मानसी। लक्ष्मण अनम्यूट करो।
यस सर, समझ में आ रहा है।
समझ में आ रहा है ना? ठीक है,
और
ओके सर।
माछी कौन है इसमें?
सर ये मानसी वसीटा है, मतलब कि महाराष्ट्र है। मानसी अनम्यूट करना।
Yes, sir.
ओके
हाँ सर को बताओ अपने बारे में।
Hello, everyone. Myself Mansi. I'm from Maharashtra, Nasik, and I've just had my master's from Dr. Babasaheb Ambedkar University from Aurangabad. I'm glad to have myself into the class. This is my second lecture right now, and I'm just trying to get on the track. Thank you.
ओके,
तो
थैंक यू।
आपको समझ में आ रहा है सारी बातें, फॉलो कर रही हो, मजा आ रहा है तुमको
Yes,
पढ़ने में?
sir. Yes, I'm on the track and trying to be on the track.
सही है। BSc कहाँ से की हो तुम?
From Pune University, KTHM College, Nasik.
वो सावित्री भाई फुले यूनिवर्सिटी से क्या, जो पुणे में है?
Yes. हाँ, yes, Savitribai Phule.
अभी मास्टर तुम्हारा अभी कंप्लीट हुआ है?
सर ये
Yes.
क्लासमेट है, हिमांगी क्लासमेट है सर ये।
ठीक है, चलिए। तो this triangle is for subalkaline magma series and this is divided into tholiatic and calcalcline magma series। हाँ, तो मैं पूछ रहा था ये जो सर्किल बनाया हूँ मैं इतना बड़ा सा, ये कौन सा मैग्मा को रिप्रेजेंट कर रहा है या कौन सा रॉक को रिप्रेजेंट कर रहा है? So I told you ना कि your magma series, all magma series is evolved from the parent magma, and which is your parent magma?
Basaltic.
Basaltic magma। तो ये क्या रिप्रेजेंट करेगा, बसाल्ट को रिप्रेजेंट करेगा कि नहीं करेगा?
Yes.
सो
GeoFU.
सो यहाँ यहीं से आप कैलकलक्लाइन में जाओगे तो क्या क्या लिखोगे? बसाल्ट, फिर अंडरसाइड लिखोगे यहाँ, फिर डेसाइट एंड फाइनली रायोलाइट। ओके, और यहाँ पे ये वाला पाथ फॉलो करेगा जो थोलेटिक मैग्मा सीरीज है, वो भी देखेंगे कौन कौन सा रॉक आता है वहाँ पे। हियर यू कैन सी दिस इज योर कैलकलक्लाइन मैग्मा सीरीज विच इज ओरिजिनेटेड फ्रॉम basalt। ओके, सो दिस इज basalt, देन andesite, देन डेसाइट, देन रायोलाइट, और basalt और andesite से मिल करके बनेगा basaltic andesite। एंड हियर दिस इज योर थोलियाटिक पाथ, थोलियाटिक magma series which is your, this is ferrobasalt because you are towards iron। ठीक है।
यस सर।
So now see, yes, let me write pholiatic magma series rocks. या चलो इसको कल बताएंगे, ये देख लो। हम्म तो यहाँ तक हमारा क्लियर हो गया ये चीज़ कि कैल्कलाइन मैग्मा सीरीज में कौन कौन सा रॉक आएगा, वी नो। बसाल्ट टू रायोलाइट। फोलियाटिक मैग्मा में कौन कौन सा रॉक आएगा, बसाल्ट आएगा, फिर बसाल्ट, फेरो बसाल्ट आएगा, फिर यहाँ पे आ जाएगा आपका पिक्राइट बसाल्ट ऑल्सो कम हेयर, पिक्राइटिक बसाल्ट एंड picritic basalt is the main parent magma for pholitic magma series, and alumina rich basalt is the parent for calcalcaline. Then ferrobasalt, then you will get tholiatic basalt, then you will get simple tholiite and sometimes quartz tholiite, and then Icelandite. So these are the rocks that you will get in pholiatic magma series, and these are the rocks that you will get in calcalcaline magma series. So yes, so all these things I think completed. See this diagram. So here you can see this silica is increases here, alkali is increases here, and this is your basalt, which is your parent magma, and here this is hawite, this is mugiarite, this is benmorite, and then trachyte. So this is the path of alkaline magma series. Okay, and especially because it is a hawite, mugiarite and benmorite, then it is sodic magma series. ठीक है, और अगर ये and if it will come here through andesite, dacite, basaltic andesite, dacite, then rhyolite, then it will be your subalkaline or especially calcalkaline magma series. So this is the line that basically represent critical plane of silica under saturation. Here there will be undersaturated rock, and here there will be saturated to oversaturated rocks.
Oversaturated.
So I hope that this things is very much clear to you. Now see here, we have read alkaline magma series, we have read pholiatic magma series, we have read calcalkaline magma series. So these two magma series is basically is your subalkaline ना, subalkaline का variety है ना. So यहाँ पे हम ये देखेंगे कि कौन सा मैग्मा सीरीज कौन से टेक्टोनिक सेटिंग में मिलेगा. ठीक है, so this is your magma series, and I am going to correlate this magma series to टेक्टोनिक सेटिंग. कौन सा टेक्टोनिक सेटिंग में कौन सा मैग्मा सीरीज मिलेगा. तो वी हैव थ्री टेक्टोनिक सेटिंग्स बेसिकली. वी हैव डाइवर्जेंट बाउंड्री which is at MOR, mid oceanic ridges, where sea floor spreading has been taken place in the oceanic crust. We have divergent plate boundary. We have subduction zone where we will get convergent plate boundary where two plate collide, and we have transform plate boundary where two plates side apart move up side apart. Generally, these two settings are very important: divergent and convergent setting. And these two settings is also very much restricted with the plates, whether it will be plate within plate or at plate margin. So generally, your MOR is formed on the plate margin. Your collision has been taken place at the plate margin, and within plate generally continental rifting has been taken place. Okay, and it will occur in the both oceanic plate as well as continental plate. But this plate margin, which is your divergent plate margin and convergent plate margin, is very much common. So suppose for MOR का example क्या है? Mid Atlantic Rift today in the Atlantic Ocean, and the best example of subduction zone is your Nazca plate is subducting below the South American plate. Okay, and you will get Chile, Peru, and Andes Mountain. ठीक, तो प्लेट मार्जिन की बात करते हैं, कन्वर्जेंट एंड डाइवर्जेंट। तो डाइवर्जेंट MOR हो जाएगा और ये सबडक्शन हो जाएगा कन्वर्जेंट। विद इन प्लेट भी होता है, बट इट इज योर कॉन्टिनेंटल का बेस्ट एग्जांपल क्या है? ईस्ट अफ्रीकन रिफ्ट, और ओशियनिक प्लेट का ओशियन में बहुत जगह रिफ्टिंग हो रही है। आई डोंट नो द एग्जैक्ट नेम। सो अब देखिए आप यहाँ पे कि जो आपका अल्कलाइन मैग्मा है, इट इज यू कैन गेट इन द सबडक्शन जोन सेटिंग at convergent plate margin, but you will not get alkaline magma in MOR in mid oceanic ridge where diversion of oceanic plate has been taking place. You will not get alkaline magma here. You will only get in convergent setting plate margin वाले में। और जहाँ विद इन प्लेट हो रहा है, यानी प्लेट मार्जिन का मतलब क्या? बिटवीन प्लेट, दो प्लेट के बीच में। और यहाँ पे विद इन प्लेट, सिंगल प्लेट की बात हो रही है, विद इन सिंगल प्लेट। तो सिंगल प्लेट में ओशियनिक कॉन्टिनेंटल दोनों जगह आपको अल्कलाइन मिल जाएगा। थोलियाटिक मैग्मा का केस का मामला ये है कि थोलियाटिक मैग्मा इज फाउंड एवरीवेयर। ठीक है, हर जगह आपको ये मिलेगा। और कैल्कलाइन मैग्मा इज ओनली रिस्ट्रिक्टेड इन द सबडक्शन जोन सेटिंग, इन सबडक्शन जोन सेटिंग एट कन्वर्जेंट प्लेट बाउंड्री। ओके, सो योर कैल्कलाइन मैग्मा ओनली फाउंड हेयर, नाइदर हेयर, नाइदर हेयर, नाइदर हेयर। ठीक है ना?
Yes, sir.
Yes, sir.
तो आज के लिए जो है इतना ही रहने देते हैं। कल टुमारो आई विल सॉल्व द क्वेश्चंस ऑफ GSI previous year papers, क्वेश्चंस रिलेटेड टू, यहाँ से जो क्वेश्चंस रिलेटेड होंगे मैग्मा सीरीज और इस टेक्टोनिक सेटिंग से रिलेटेड। किसी का कोई सवाल है यहाँ तक? ठीक है सर, आई एम गोइंग टू एंड दिस मीटिंग।
Okay, sir. Okay. Meeting end, sir.